In the third video of our introduction, we will cover the subject of displaying our results. Each component incorporates a set of results in its property menu. The same thing is valid for the pipes. Inside the property menu of each pipe, we can find pipe values which give us information on the material properties of our fluid in this specific pipe. We can display these results either by opening the components like I showed just a second ago, or we can just place our cursor above a line and we see a tooltip showing specific results of this component. The same thing with the pump, or for instance with the turbine. We can manipulate the information showed in the tooltip in the application settings, which you find here. The menu display. In this menu, you can change the tooltip setting for each component. In this list, values indicated with an I are input or specification values, and values with an O indicate result values. We can select and deselect each one of them. So let's get rid of the nominal isentropic efficiency of our turbine, and we will see that it will vanish from the tooltip of our turbine. A more common way to display the results in our cycle is to use the value crosses, which we will find in the component toolbar. We select the value cross with a left click. The cross indicates which line will be selected for our value cross. I click on the line and drag the cursor in order to resize my value cross. We can position and resize the value cross, and we can also add units to it by double clicking on the value cross and choosing the unit option in the values menu. We could, for instance, also change the arrangement of the values displayed in our cross and the amount of values displayed. In this case, I can, for instance, get rid of the right empty column and have a single column table displaying the live steam parameters. I keep it simple, and in order to display other values, I will just copy and paste this value cross to other lines. Ctrl C, Ctrl V creates a copy of this value cross, and we place the value cross with a left click. This would be our steam before the condenser. We would like to know the cooling water outlet parameters, the cooling water inlet parameters, and the feed water parameters. Another valuable information would be the power generated by our cycle, which we can do by extending our topology with a generator. The green line indicates a mechanical shaft, which transfers mechanical power to the generator. We extend the electrical line of our generator and add a value cross here, which stays empty because this is a new line and there are still no results available for it. I simulate the cycle again, and you see, given a certain parameterization of our cycle, we get a power output of 146.6 megawatt. In order to change the units the results are displayed in, I have to change the setting of the line the value cross is placed on. So as soon as I change it to megawatt, the display will be in megawatt. I can also change the unit system from a global level in the application options. In the submenu International Settings, I can, for instance, change the unit system, which is by default set to the option from component, which means the displayed unit will be the one specified within the component, to SI values, UK values, or to a user-defined system. You see, in the user-defined system, the default setting is also from component, but I can also change this setting and display all unitless values as percentages. Now all my efficiencies should be displayed in percent. The isentropic efficiency of my turbine is 88% and the mechanical efficiency is 99.8% now. Another very valuable tool is to display certain values in text fields. I can select a text field from my component toolbar. With a left click, I start the text field and I drag the cursor in order to resize it. A right click ends the selection. The value I would like to calculate now would be the gross efficiency of our cycle. We have the useful power output given by the generator, and we need the power input in order to calculate our expenses. This logical line will display the power needed in order to create a live stream of the demanded parameters. In order to calculate the gross efficiency, I need to divide the useful power by the expenditure, and I will perform the calculation within this text field. Before I write the equation, I would like to change the name of the lines which incorporate the data needed in order to make them self-explainable. I can double click on this electric line and change its name in the basic properties. It will be P power out. And the name of our logical power input will be power in. So our gross efficiency will be power out point Q, which is the power in the power out line, divided by the power input, and I address the power with a dot and a Q. So as you can see, our gross efficiency should be around 38.2%. I would like to change the format of the displayed efficiency, and therefore I will add a blank space here, multiply the result by 100, and reduce the amount of decimal digits to 2 decimal places. I start to change the format with an apostrophe, a percentage sign, the dot and a number indicate the amount of decimal digits, and I end my format with an F, which means floating point. This is the gross efficiency of our cycle. Another new feature, which is available starting from Epsilon version 10, is the possibility to input data via a text field. I add another text field to my cycle, open it, and activate the input capability of this text field. I would like to input the nominal steam pressure of my cycle. So I will name this text field PLS for pressure of the live steam. And I will put a value of 150 here, which means our input value will be 150 bar. I address this text field by typing P underscore LS, and I address the text written in my text field with dot text. As you can see in the tooltip, the value of my live steam pressure should be 150 bar now. I simulate it and the live steam pressure changes to 150 bar just as expected. And now I can use this value as an input field for my cycle. So let's sum up what we should have learned in this lesson. We learned that after a simulation, result values are available for almost each component and each line. We learned about various types of result display, such as the tooltip and the value cross. We learned about the text fields, which can be used to perform calculations. And we also learned about the input capability of our text fields. Another thing we should keep in mind is the way to address certain values of our components. The nomenclature is first the name of the object, a dot, and then one of the specification or the result values. In the next lesson, I will introduce you to the controller elements incorporated in Epsilon.